Welcome to the next concept on conditional probability. This is the brand new concept introduced in the math syllabus that you have not learned before in secondary school. So this is your first JC probability concept, right? And what was the whole idea of conditional probability? The whole idea of conditional probability is basically calculating the probability of an event given that, I'm just gonna underline this over here, given that another event has occurred. Okay, so I'm just going to use an example over here to show you the concept. So let's say my sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over here, right? My sample space is like that. Now let's say I have event A. Event A is the probability that the number is odd, okay? And let's say B over here is the event that the number is bigger than or equals to 5. So if I were to draw out the event diagram, right here is my and here. Okay, so this is my Venn diagram over here. This is my universal set. I'm just going to draw the symbol properly. This is A, this is B. So we can see that A is odd. That means A contains 1, 3, 5, 7, 9. So 1, 3, 5, 7, 9. And then for B, it contains 6, 7, 8, 9, 10, right? And then that would mean that 2 and 4 will be outside. Okay. So if I ask you what's the probability of A happening, right? Given that A is odd by itself, right? PA by itself is simply just 5 out of 10, right? Because I have 5 odd numbers out of 10 numbers, and that will give me half. Now, what's the probability that B itself is bigger than or equal to 5? This would mean that the probability of A would be 5 out of 10 as well, because I got 5 numbers out of 10 numbers, and that will give me half. But now, if I ask you, what is the probability of A given that B already happened? So what does that actually mean in terms of English? Given that B has already happened means that now our sample space is just B. So given that our sample space is just B now, because given that B has already happened, means that we don't care about anything else that is not B, right? I can just track out all of this because now our sample space is just B. So you think that given that B has already happened means that it could either be 5, 7, 9, 6, 8, 10, right? Means that is 5, 7, 9, 6, 8, 10. So given that B has already happened, what is the probability of happening inside of B? You can think of it about it that way, right? And we can see that happening inside of B, whereby the numbers are odd, will only be this 3 over here. So this probability be 3 out of 6 over here, which will give me a value of half over here, right? Because given that B has already happened, the sample space has been reduced to 5, 6, 7, 8, 9, 10, right? Anything else that is not inside of B is automatically ignored because now we only care about what happens inside of B. And then we are basically trying to find out how many outcomes A are there inside of B. So we often call B the reduced sample space because given that B has happened, we reduce the sample space to only B. And we're just trying to find out how many outcomes are there of A inside of B, right? So this is what we call conditional. And the reason why it's called conditional probability is because we only count the outcomes of A on the condition that B has already happened. So this is also what we know as conditional probability. And a very simple way to think about this is in order to compute the probability, it is given that B must have already happened. So just must have already happened. So typically in notation wise, this is how it's written. So it's usually written as such. So this line over here means given. So we read this as A happening given that B has already happened. And the formula behind this is A intersect B over probability of B, right? Because now our B over here is our reduced sample space. And then the top one over here would be the sample space that has both A and B in it. So you can see that in my example here, this 6 over here is the whole thing of B. And then this 3 over here is here, right? Where it's the intersection between A and B. So therefore, that's how the formula actually works. Where I'm just trying to find out what is the intersection between A and B as a ratio of the entirety of B. So from this whole thing here, we're just trying to figure out how much of A intersect B is part of B. That's basically all we're just trying to find in terms of conditional probability. So the most important thing here to remember is that for conditional probability, we always take it that the given condition has already happened and therefore the sample space is now reduced, right? So reduced sample space, and that's how it basically works. All right, so now that I've gone through the conditional probability concept, feel free to pause this video anytime you need to go and internalize your thoughts, because right now we're actually going to go through this concept using a very simple question over here. So feel free to pause this video right now to attempt this question. If not, I will go through this question together with you. So jumping right into this question over here, two ordinary dice, and we are trying to find out that the sum on both dice is 8, given that the numbers are equal. So you see that given that the numbers are equal, means that to begin with, our reduced sample space is already just 1, 1. This is one pair. 2, 2. This is another pair. 3, another pair. 4, 4, another pair. 5, 5, another pair. 6, 6, another pair, right? And we want to find out the sum. So we can see that for the sum is only one pair over here, right? The sum is 8. So therefore, the probability for the first part is just 1 out of 6, because our reduced sample space to begin with has only 6 outcomes. Given that we only have 6 outcomes and 1 outcome fulfills the condition that we want, the probability is just 1 out of 6. Okay, now for the next portion, double I. Both are equal given that the sum is 8. So now this one is the reverse, right? Given that the sum on both of the dice is 8. Okay, this is I, this is double I. So for double I, what is our reduced sample space looking like? So our reduced sample space for double I would be 2, 6, right? 6, 2, and then 4, 4, and then 3, 5, and then 5, 3, right? We can see that in our reduced sample space, only this set, right, give me 8 as a sum. And both numbers are equal means that only this, because only this are both numbers equal. Therefore, the probability of double I is as simple as just 1 out of 5 favorable outcomes, right? And that's the final answer to double I for sure. Okay, so just remember for conditional probability, as long as you remember that the sample space is always reduced to the given condition, that's all you got to do. Okay, any questions, let me know in the comments below. Otherwise, that's it for this concept. And in the next video, actually going through a recap of what independent intents are and also practicing some questions of that. Okay, if not, I'll see you in the next video.